Hello everyone. Uh, in the previous video, we discussed about the atomic orbitals and what is atomic orbital. So atomic orbital means probability of finding electron. Of finding electron. The atomic orbital represents the probability of finding electrons. So we can say that atomic orbital can be distinguished by size, shape and orientation. Shape orientation of orbitals of electrons in different orbitals. So for size we can use principal quantum number, for shape we can use azimuthal quantum number, for orientation we can use magnetic quantum number. These size, shape and orientation can be represented by three quantum numbers, that is principal quantum number n, azimuthal quantum number l, and orientation can be represented by ml, which is called magnetic quantum number. And spin also. Spin represents the orientation or spin of electrons in its orbit. So these mainly the atomic orbital can be represented by size, shape and orientation, which is called quantum number. This quantum number gives the address. We can say that it gives the address of an electron in an atom. Complete address. By finding the quantum number, by knowing the quantum number, we can know the address of an electron, what is the size of the shell in which electrons are present, what are the shape of the orbital, and what are their orientations in different orbitals. So let's start with the quantum number. Quantum number. It is the identification number. Identification number which represents size, shape, orientation, spin of the electron, in its own axis, in an orbital. Or we can say that in a shell or in an atom. So it is the identification number which represents size. We can calculate size by principal quantum number, shape, orientation by azimuthal and magnetic quantum number, and spin by quantum number. Spin of electrons means it gives the spin of a particular electron present in an atom. So let's start with, we can see that there are four types, 1, 2, 3 and 4 types of quantum numbers. The four quantum numbers are, first is types of quantum number. First is principal quantum number. Represented by M. Second is azimuthal quantum number, or it is also called angular momentum. Angular momentum quantum number. We can calculate the angular momentum by this. Angular momentum quantum number or subsidiary quantum number. Subsidiary quantum number. And it is represented by L. Azimuthal quantum number is represented by L. Third is magnetic quantum number. Magnetic quantum number is represented by Ml. And fourth is spin quantum number. Spin quantum number represented by Ms or simply S. Spin quantum number. Let's start with the principal quantum number. What is principal? We know this n value and calculate various things by this n value. So, principal quantum number gives the information about the size of the atom. We can calculate the size of the atom by principal quantum number. So we can simply say that it represents the size and energy of an atom. It represents the size and energy of an electron in an orbital. In a shell or in an orbital. So this principal quantum number, which is denoted by n. If for the value of n, if n is 1, 2, 3, 4, 5, this gives the information about the cell. The cell is, if it is 1, then cell is K, L, M, N, O, likewise. And second thing, we can calculate the size of the atom. So there are various things we can know or we can represent by this principal quantum number. So this quantum number, it tells us about number 1, size of the atom. Size of the atom. It tells us about the size of the atom. If, or we can say that with the increase of number of shells, size increases. Or we can calculate for hydrogen atom as R is equal to 0.529 n square by Z angstrom. So we can calculate the size of the atom like this. Second thing, we can calculate the energy of an electron by principal quantum numbers. You know the calculation of energy, and in the calculation of energy we represent this n. Like, second thing is, it represents energy. It tells us about energy of an orbital, of an electron, energy of an electron. Greater the number of n, higher is the energy. Greater is the number of n. Number of n means principal quantum number. Higher is the energy. Is the energy, as energy depends on the number of orbitals. Third is, we can calculate the number of orbitals present in different shells. It tells us about number of atomic orbital in a shell by n square. N square. This n square gives, if n is n is equal to 1, then number of orbitals present in this is n square is equal to 1 square is equal to 1. If n equal to 2, this is 2 square is equal to 4. N equal to 3, n equal to 4, then it is 3 square, and this is 4 square. It is 9, and it is 4 square is, it is 16. For n equal to 1, it is only S shell is present here. For n equal to 2, S and P both cells are present here. Both cells are present here, and for this is 1s and 1s and 4p, 3p, px, py, pz. 3p means px, py and pz orbitals are present in it. So total number of orbital is 3 plus 1, 4. For third shell, it is 9. 1s electron, 3 p electrons, p orbitals, and 5 d orbitals are present in the third shell. That means 5 plus 3 plus 1 equal to 9. There are 9 orbitals present in the third shell. For fourth shell, it is 1s orbital, 3 p orbital, and 5 d orbital, and 7 f orbitals are present in the fourth shell. So the total is 7 plus 5 plus 3 plus 1 equal to 16. So we can calculate the total number of atomic orbitals by the this quantum number n, by n square. And you all know the fourth information that we can get from the principal quantum number is the maximum number of electron. The maximum number of electrons in a shell is 2n square. You know very well the 2n square. So these are the, we can also calculate the angular momentum, as you know that mvr is equal to nh by 2 pi. Here n is the principal quantum number, so we can calculate the angular momentum, the momentum, etc. by knowing the principal quantum number. So it is very important quantum number. We can get many other things like energy. We can calculate energy by principal quantum number and azimuthal quantum number as well. So let's start with the azimuthal quantum number. Next is the second quantum number is azimuthal quantum number or angular momentum quantum number, or is also called subsidiary quantum number, which is denoted by L. It defines or it determines the shape of the orbitals in three-dimensional, we can say that three-dimensional. It defines the shape of the orbitals in three-dimensional region, or it is defined as the it determines the shape in three-dimensional region. For different value of n, for value of n, L is equal to n minus 1. 0 to n minus 1. If n equal to 1, n starts from 1. Yes, there is thing which is n quantum number. The principal quantum number starts with 1, 2, 3 and 4. There is no 0 here. At 0 there is no probability of finding electrons. So principal quantum number, there is it starts from 1, 2, 3, 4, any positive integer. If n equal to 1, then L equal to 0, and if n equal to 2, then L equal to 0, 1, n minus 1, 0. It is ranges from 0 to L to n minus 1. 0 and 1. For n equal to 3, it ranges from 0, 1, 2. And if n equal to 4, then n equal to 0, 1, 2, 3. n minus 1, 3. Up to n minus 1. If L equal to 0, 0 represents s orbital. This 0 represents s orbitals. For the value of L, if L is 0, it represents S. If it is 1, then it represents P. If it is 2, then it represents D. And if it is 3, then it represents F. And for if 4, then it represents G and H accordingly. So this gives the information about the subshells. This gives the information about the subshells. These are the subshells. So this quantum number, azimuthal quantum number, tells us about the subshells. It determines the maximum number of orbitals present in a subshell. First thing, it tells us it tells us about the subshells present in a shell, present in or in an atom. Second is, it represents the maximum number of orbitals in a subshell. By 2l plus 1. 2l plus 1. Second responsibility is 2l plus 1. If L equal to 0, then 2l plus 1 equal to 2, 0, 0 plus 1 equal to 1. That means here we can write that maximum number of orbitals. Maximum number of orbitals. If L is equal to 0, 2 into 0 plus 1 equal to 1. If L equal to 1, 2 into 1 plus 1 equal to 3 plus 1, 4. L equal to 2, then 2 into 2 plus 1 equal to 5. Likewise. So the maximum number of orbitals can be calculated by n square, can be calculated by principal quantum number or azimuthal quantum number. If you know the principal quantum number, we can calculate the maximum number of orbital. We can calculate the maximum number of orbital by n square by principal quantum number and 2l plus 1 by 2l plus 1 means by azimuthal quantum number. We can get the maximum number of orbitals. 2 plus 1, 3. 2 plus 2, 1. 4 plus 1, 5. We can get maximum number of orbitals by 12 plus 1. Next, we can also calculate the number of nodes where there is no probability of finding electron by n and l. First thing, what is node? What is node? Node. What is node? Node or radial node or axial node. There are two types of node, radial node or angular node. So radial node or angular node, we can calculate these nodes. What is node? Node is where there is no probability of finding electron. The probability of finding electrons at a node is 0. So we can calculate the nodes in different orbitals by azimuthal quantum number. For by the formula, so the third thing which it tells azimuthal quantum number, the total number of nodes or nodes present in an orbital by n minus L minus 1, by n minus L minus 1. We can calculate the radial node by this method. If n equal to 0, L equal to 0, so n minus L minus 1 equal to 0. So n is for n equal to 1, it is never be 0, n equal to 1. The probability of finding electron n minus L minus 1, L is equal to 0 means 1 minus 0 minus 1 is equal to 0. So for s orbital, n represents s orbital and n represents first shell and L represents s orbital. For s orbital, the probability of finding electron, for 1s orbital, the probability of finding electron is 0. So we can say that for 1s orbital, node is, which node? Radial node is 0. N equal to 2 means L equal to 0 and 1. There are two terms for